Hello. Today we are going to discuss the staircase problem. First, we need to know what the problem statement is. Here you see the problem says that it is to find out the number of ways one can reach a particular stair where at most 2 stairs one can jump. What is the condition? One has to reach a particular stair, but one can jump at most 2 stairs. For example, say we are taking a staircase like this. Say this is a staircase. This is the ground. Stair number 1, 2, 3, 4. So to reach 1, you require to make a single jump. To reach 2, how many ways you can reach 2? Either you first go to 1, then go to 2, or you can jump directly from the ground to 2, because you are allowed to jump at most 2 stairs. So there are 2 ways to reach stair 2. So to reach stair 1, there is only one way. To reach stair 2, we see that you can do it by 2 ways, either making a direct jump or taking 1 step at one go. So there are 2 ways. And what about stair number 3? If you want to reach stair 3, what you can do, you simply go 1 stair at a time. That means 1, 1, 1. Or you simply jump to stair 2, then take 1 step. That means another way, first 2, then 1. Or simply jump to stair 1 and then make a jump to go to 3. That means 1, 2, another way. So there are total 3 ways. Similar to reach stair 4, what you can do, you can take that simple 1 step at a time, or you can directly jump to 2, and from there you can directly jump to 4, 2, 2, another way. Or you can jump to stair 1 and then stair 2 and then make a jump to stair 4 by taking 2 steps at a time. Or you can directly reach stair 2, then go to stair 3 and then reach stair 4. Or what you can do, you can go to stair 1, then make a jump to stair 3 and then reach stair 4 by taking 1 step. So how many ways are there? These are the number of ways maximum by which you can reach stair 4. Total number 1, 2, 3, 4 and 5. So 5 ways are there to reach at stair 4. Now we need to find out number of ways by which you can reach a nth stair. Nth stair. How this is possible? This might be possible for smaller number of stairs, but if it is a big number, then by simply doing that kind of simple calculation, it is not possible. We need to take help of a program. But if I go for recursive program, you know what is recursive program? That is what? That is calling a function over and again to do some task repetitively. Say for example, we were discussing about stair number 4. To reach stair number 4, say I'm drawing the figure again. You are starting from the ground always, stair 1, stair 2, stair 3 and stair 4. So to reach stair 4, you see, you can reach stair 4 either from stair 3 or from stair 2, from 3 or 2. And stair 3, you can reach from stair 1 or from 2. So 3 from 2 or from 1. And 2, you can reach from 0 or from 1. Similarly, 1, you can reach from only from ground. For these 2 also, the same thing, 2 and 1. In recursive procedure, what happens? A function calls itself until the solution is reached. But the problem with recursion is the same calculation is repeated over and again. You can see that for stair 2, you are doing a calculation, again you are doing the same calculation and another step. But you see how many ways you can easily see this one. This is one way. this is another way, this is another way, fourth way and fifth way. So 5 ways are there to reach at stair 4. But using recursive function is time consuming. We usually avoid recursion because of time complexity, increase in time complexity. So we need to think about some efficient solution procedure. There comes the role of dynamic programming. But before we start solving this problem using dynamic programming, we need to know when we will think about dynamic programming. Better to say, whenever we are dealing with a problem, how can you know that dynamic program is suitable for this problem? Other way, which problem is a candidate of dynamic programming? To apply dynamic programming, we need to first check whether the problem given can be divided into sub-problem, and by solving the sub-problem, we can reach to the problem or not. Here, we are trying to use a calculation done before for the calculation of further problems. That means solve a sub-problem, use the calculated value for the next sub-problem solution. And this way you can reach the ultimate solution. For our example, that to reach at stair 4, to find out how many ways are there to reach at stair 4, if we know that how many ways are there to reach stair 3 and how many ways are there to reach stair 2, then simply by adding these two, we can know that how many ways are there to reach at stair 4. Say, for example, to reach at stair 2, there are X number of ways, and to reach at stair 3, there are Y number of ways. So if we just add these X and Y, that would be the answer for stair 4. That means this is X plus Y is the number of ways by which we can reach at stair 4. And similarly, if we consider about this stair 3, if we know how many ways are there to reach at stair 1 from ground and to reach at stair 2 from ground, then say it is P. P is the number of ways to reach at stair 1 and X is the number of ways to reach at stair 2. Then the number of ways to reach at stair 3 is P plus X simply. So what we are doing, we are trying to use the pre-calculative value, that is the calculation are done for the previous stairs to get the solution for the next stair. This way, starting from the beginning, so for your example, say from the stair 1, we can gradually reach to our desired stair, that means stair number 4 in our example, right? So here we are using an array for doing this. But what will be the size of that array? See, here we will use the index value as the stair value or the stair number of stair. That means, say if it is A is the array we are taking, what will be the size of the array? If n is your number of stairs, in our example it is 4, then the size of the array should be n plus 1. Why sure that? Because if 0 represents you the ground, 1 represents the stair number 1, 2 represents the stair number 2, and 3 represents the stair number 3, and 4 represents the stair number 4. So we need the solution for stair number 4. Here, this value will be the answer. So what is the size here? 0 to 4. That means size is 5. So if your desired stair number is 4, then your array size should be 5. And how you are proceeding? You start from the beginning. Here, for ground 0, we don't need any value because it is the ground. You don't need any jump to reach at ground 0. But to reach at stair 1, you need just one step. One way is there to reach from ground 0 to stair 1. Only one way. But what about the stair 2? We know there are 2 ways. These are the 2 initial values we would first consider. There are 2 ways. We can directly jump from ground to stair 2, or first stair 1, then stair 2. So there are 2 ways. So we will simply initialize these 2 values and proceed from stair number 3 to our desired stair number. Maybe it is 5 or 6 or anything. Start from that index number 3 and proceed by using the pre-calculated values. Say for example, for stair number 3 we are using these two values 1 and 2. Add these two, we are getting the value 3 here. And similarly, to get the answer for stair 4, we are adding these two values, because to reach tier 4 you can directly reach from 2 to 4 by having a single jump, or you can reach from 3 to 4 by having a single jump. So adding these two values, you will get that value 5 here. And to reach at tier 4 5, you are using the same procedure. Add these two values, you will get the answer for tier 5. So rightly you understood that it is a Fibonacci series you are using. We know the Fibonacci series, Fn is actually function of Fn minus 1 and plus n minus 2. So you are using this formula here cleverly as dynamic programming formula. So let's see how the program runs. We are using this thing here. Instead of the function, what we are doing, we are using an array. So the calculation would be like that. Initially, the value of A1 is 1 and value for the stair 2 is 2, and you are starting running a loop for I is equal to 3 to I less than equals to n, because y less than equals to, you want to reach at stair number n. So go up to n and I plus plus, enter into the loop, get the value for the ith stair by having the calculations made previously for I minus 1 and I minus 2 for the previous two stairs, from which you can directly reach at ith stair. That's enough. That is the thing. And what will be the answer? Obviously, the answer would be the nth value. That means an should be the answer. Let's go to the program. We are using C++ here. So enter into main and simply declare a variable. You need to declare a variable. I is also required. So ask the user to enter the stair number to reach. Enter the stair number to reach. That is n. You are asking, accept that value n, and what will be the size of the array? The size of the array should be a, as we discussed, n plus 1, because this is just because we are using the index numbers as the stair number. So run a loop like that for I equals to, as we need to, I forgot, we need to initialize the first locations of the array A1. For the stair 1, you require only one way, and for the stair 2, we require two ways. These are the two initial values we are having, and you start from the third index. That means, sorry, for the fourth index, but it is the stair number 3. So go up to nth stair, and every time you enter, you calculate the value for the ith stair by having the two previous calculated values for the I minus 1 stair and I minus 2 stair, because these are the two stairs from where you can reach the ith stair. So you are using these two values, adding them, and you are getting the total number of ways to reach the ith stair. That is, so your answer would be an, the last value. Mind it, in case of dynamic programming, always, be it a one-dimensional array or two-dimensional array you are constructing, the last value will be the answer. Always the last value is the answer in case of dynamic programming. Let's run the program, save it and run it. Say for stair number 3, it is 3. You can check whether it is correct or not. For stair number 3, you can see it is 3. For stair number 4, it should be 5. For stair number 5, it should be 8. Let's see for another stair number. For stair number 5, it should be 8. It is showing you the correct answer. The last one for stair number 4, it is 5. So it is a very simple problem in dynamic programming, but it is the building block. If you understand, for dynamic programming, the main idea is use the previously calculated value, pre-calculated value, to calculate the next value. If it is possible, then that problem is a candidate for dynamic programming. In dynamic programming, you can reduce the time complexity, but one thing you must remember, there are some problems what cannot be done, cannot be solved using dynamic programming. I will come up with several serious coding down dynamic programming later. So if you think that it is interesting, please subscribe my channel, view, like, and comment. Thank you.